All right. So, Nate, the other thing that we wanted to talk about was journaled file systems, right?
Yes, journal file systems. I'd say most modern file systems are in fact journaled. Maybe that's too broad of a statement.
No, I think that that's accurate. And we mentioned at the beginning of the show that ext3, the big difference between ext2 and ext3 was ext3 had a journal log.
Yep.
So, Nate, do you know how journaling works?
I mean, I have this basic concept that a journal is this additional sort of log, right, of what's on the disk, where it lives, things like that, that helps make the file system more resilient to interruptions and errors, right? How it works, man, I got no idea. It's magic.
Okay. So, so like how it works is there's actually a file called the journal log that's in your file system. It is embedded there. And in fact, if we looked at ext4, it'll actually tell us the inode number that goes along with our journal log if we want to try and find it.
Right.
In the early days, it actually put down a file, like a file with a dot as its name. But we figured out that people would find that and mess it up. And so we just like obscure it entirely from
What's
them.
this thing taking up space on my drive? Delete that.
Delete it. Yeah. All right. So there are a couple of different ways that you can run your journal. The most common way and the default way is that your journal will include metadata about disk transactions. And so when you're going to do a file write, it really only applies to writes. When you're going to do a file write or a file create or making a new file and allocating new stuff, it'll open the journal log and put in an entry that says, oh, about to do this disk operation, this file system operation. And then it goes and does the file system operation. And then it puts in a journal log entry that says this file operation is completed. And so if you have a power outage and the machine comes back on, it can look at the journal log and it can look for transactions that have an open transaction message where it was going to go do something, but it doesn't have a matching close transaction message, which means it didn't complete. And so oftentimes what will happen is it'll go out and like remove any partially completed bits of the file transaction. You just lose that file transaction.
Right.
But that keeps
Instead
you
of
from
losing a
having,
whole disk or you lose a file, a couple
yeah,
files.
and it keeps you from having like a corrupted file or like other weird things happening on your file system. So we'd rather have no data than like not data that's accurate, right? Because nobody cares about file systems until they can't get their data back, and then they really care. So if
Right.
we thought that it was written out, and then we come back and it's all mangled because it was only half written out, and then we had a failure, that would be a place where somebody would get really mad. So that's like in metadata journaling what happens. We put it in this open transaction, we go out and we do the data write or whatever, and then we put the closed transaction message in. That's how we know it was completed successfully. If it's not completed successfully, we have some stuff to try and mitigate partially written or partially applied file changes. The other way you can run journal is in a mode we call journaled mode. And for that one, it actually like puts in the open transaction message, hey, I'm going to do this file IO for the file system. And then it actually puts in a copy of what it's going to transact. And then it goes out and does it. And then it has a closed transaction message. So when you're running in this way, if you have a power outage or something that keeps the transaction from completing, when we look in the journal log, we see the entry of the journal. We actually don't see the matching close, but we also have all the data that was going to be written. And so we could just replay that transaction and re-execute it. And we know what data is supposed to go there. So for like the extremely not fault tolerant person where they want that extra security and or the extra resiliency that provides, they can do it. The downside is now they're writing every file twice. Right. Once to the journal log, so it can be journaled, and then once to the disk, so that we can make sure that the transaction completed successfully. And so there's some stuff that you can do to try and mitigate that. Like you can actually run your journal log on a different device. So you can write your file data over here to this journal and then come to your file system and actually do the stuff. You can actually do them both at the same time so that you're not constantly waiting on the journal log to become available that's stopping your disk IO from happening. So there are some people that run it in that mode, but like it's much, much, much more IO intense. And that is
Right.
not the default way that we run it.
Right.